In the previous video, we saw POJOs, or plain old JavaScript objects, just a recap of how those work. In this video, we'll talk about mixing some data with functionality together in the same object, which is kind of the stepping stone towards full OOP and working with classes and design patterns. So imagine I have a couple of functions. We're working with triangles, specifically right triangles. So if you don't remember right triangles, it's not a big deal, but we have three sides. There's a 90-degree angle. The longest side is opposite that 90-degree angle. It's called the hypotenuse. It doesn't really matter though. You can just trust these functions work. So we have a getTriangleArea. It expects the length of side A and side B. And then we also have getTriangleHypotenuse. This will give us the length of the hypotenuse based on side A and side B. Again, don't worry if you have no idea what those terms are, but I'll just show you that they work. So we have getTriangleArea. Let's do it for a 3, 4 triangle. Side A is 3, side B is 4, and we get 6. Great. We also have getTriangleHypotenuse. Triangle hypotenuse, which should be 5 if we do a 3, 4 triangle, and we get 5. Great, that works. Now let's say I have a separate triangle, which is a 5 and a 12 length. So A is 5, B is 12. I'm going to have to call these again, right? getTriangleArea for 5, 12. And then I have to do the same thing again if I want to get the hypotenuse. 5, 12, the hypotenuse is 13. And then let's say that I have 10,000 triangles in a database and I want to get the area and the hypotenuse for each one. I'm going to have to call these functions and pass these arguments individually in the right order each time. And this works just fine, right? This is just a basic building block of JavaScript, writing a function. But it gets a little messy. We have to keep track of these functions. This is hypothetical with just 2 functions, but maybe we have 10 or 20 different triangle-related functions, things that have to do with right triangles. I don't know. I can't think of any other things you could really do, but I'm sure there's a lot of geometry here. It gets messy and tricky to keep track of all of these different functions and all of the return values. So what we can do is combine our data with our functions in an object. As we saw in the previous video, we can store properties or just numbers, values in an object very simply. A, in this case, is set to 3. B is set to 4. Then we can also store functions as values in an object. So we have a getArea property set to a function and a getHypotenuse property also set to a function. It's the same code from these functions here, but the body of these functions is quite a bit different. You'll see we're using the keyword this here. The keyword this refers to this particular object. Now, we'll have a whole section talking about this. It doesn't always refer to the thing you want it to, but in this simple example, the keyword this just refers to this whole object. So this object .a is going to be 3. This object .b is going to be 4. Same thing here. This .a, 3. This .b, 4. So if I run this code, right, this represents a single triangle now, just one right triangle that has a side A of length 3, a side B of length 4, and 2 functions. Technically, we call these methods. A function that lives on an object is called a method. Terminology doesn't really matter for now. I can call something like myTry.a just to see what the value is, myTry.b, but I can also execute getArea. I no longer have to pass arguments to it, and I get 3.5. If I do myTry.getHypotenuse, I get 5. If I decide, actually, this triangle has now changed sizes for whatever reason, I can set myTriangle.a to be 5. myTry.b will be 12. And now if I do getArea, we get something entirely different, 8.5. The first time I called it, I got 3.5 because A and B were 3 and 4. Now I've changed A and B to be 5 and 12, right? If we look at myTry, we have A is 5, B is 12, and these 2 methods here, these functions, are looking at whatever the current value is for A and B in this particular object. And of course, I can do the exact same thing, myTry.getHypotenuse, and now we get 13. So is this better than just having 2 functions? Probably not, because these are more reusable, right? I could have 5 triangles, and each of those triangles I just pass in as arguments. But one thing that is nice about this is that we are wrapping together data with functionality. The problem is that it's not really repeatable. What if I need a second triangle? So I want my 3, 4 triangle, and then I want another triangle, my try 2, sure. And my try 2 will be 5, 12, or A will be 5, B will be 12. This works, right? I can try the first one, my try dot get hypotenuse, and we get 5. And I can do my try 2 dot get hypotenuse, and we get 13. They each have their own data. They each have their own functions. Everything works nicely. They're wrapped up. It's cute. But this is really not repeatable. This is a huge pain because every time I have to make a new triangle, again, imagine I have 10,000 triangles I need to keep track of for some reason. I'm writing some code to take an image and vectorize it with a whole bunch of triangles all over it. I don't know. I'm struggling to come up with an example there, but imagine I need 1,000, 10,000 of these. I'm going to have to rewrite get area every time, even though it's identical, right? This is the exact same code as this, but it depends on which object it lives in. Get area in this object, this dot A refers to 3, this dot B refers to 4, this dot A down here refers to 5, and this dot B refers to 12. I can change these at any point, and then this will use the most recent value. But whatever I do, if I need multiple triangles, I'm going to have to make a bunch of these objects. It does help us mix data and functionality. Related functionality lives together, but it's a pain in the ass, pain in the butt. When we have more than one triangle, difficult to maintain. We'd need 1,000 copies of these functions if we have 1,000 triangles. It's a waste of memory. It's a waste of just space and time for us to write. So we do have a better option that we'll see in the next video that allows us to combine functionality with data using